All right, so this section is 221, graphing linear inequalities. And the thing is, it's going to be very similar to how we graph regular linear equations. Okay, they're linear. We're all dealing with linear here, but the inequalities are going to come into play as we work them out. But the same process, the same slope-intercept form of the equation here for a line we're going to be using in order to deal with these problems. Okay, so the simplified part is to get your inequality in the form of y equals mx plus b. So tell me in the chat, what do we need to move? What do we need to move here so that y is alone on the left side? What should we move to the other side? What do you think? Yeah, let's move that 3x. Watch, minus 3x, minus 3x. Now I want to match the form, so I'm going to put negative 3x plus 2. Because look, y is equal, in this case, greater than, mx plus b. Okay, so we did the first step. We simplified it so that it's in the proper form. And you know what? We're already prepared to graph this. Okay, so we're graphing this right here. Now, just to remember, using the slope-intercept form, we got our y-intercept. It's our b value. We got our m. We got our slope. Okay. So just like before when we were graphing lines, you start by plotting your y-intercept. Okay. That's 2. Here's the y-axis, so we're going to be here at 2. Oh, okay. All right. Now remember, that's kind of like anchor point. Now you got to find your next point using the slope. So it's like a step. Look at this step. It's minus 3 over 1. Minus 3 is our slope over 1, so that we can think of it as rise over run. So that means it's going to go down with that negative 3. It's going to go to the right with the positive 1 over run. So watch. 1, 2, 3 over 1. 1, 2, 3 over 1. You can go the other direction. Up 3, left 1, up 3, left 1. And now we have our points all in one line. All right, so look. We're already mostly done with this. We just plotted the y-intercept. We just found the slope to get our next point. And sorry, this is out of order. Now we got to look at number 3. Because when we have inequalities, well, I'll just say when we have a line, we'd be done and we'd just make our line if this was equal. If this was an equation, I just would make my line and that would be done. But we don't have a line. We have an inequality, a linear inequality, which is a little different. So we have to look here and remember that when it's just less than or greater than, it's dashed. When it could be equal, it's solid. So is this going to be dashed or solid? Tell me in the chat. Dashed or solid, guys? Dashed or solid? What do you think? Good. I see a lot of dashed. So you guys have seen this before. It seems like you may have seen this before. And has anybody seen my ruler? No? You guys can't see my ruler? Whatever. You can make it work without a ruler. Dashed line. Dash, 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 dash. Okay. It's a dash line. So far, so good. So far, so good. Yeah. Okay, we're at our last step already. We figured out it was a dashed line because it's just greater than. So now I need to go in here and I need to look at my fourth. The fourth is about shading. The last thing you look at is look at if y is greater than or if y is less than. Because look, here's my dashed line. If y is greater than, as we have in this case, we're looking for the y values that are greater. Where are the y values that are greater than this line? Is it up or down? The y values that are greater are up. So what I'm going to do last, I'm going to, you can use your pencil or your pen, or if you have a highlighter, we're just going to highlight all that area. Because it's y is greater than the function, which is this dashed line. So I'm looking for the y values that are greater. So the y values that are greater are up. If this was less than, I would shade below. All right. Next. Give me a thumbs up, sideways down for the 3 people that have videos on today. All right. Sideways still. Okay, next example will help with that. Okay, let's keep going. All right, now we're going to look at this guy. I'm even going to fold it. All right. Now we got this guy. Now, for this, is this in the form, or do we have to simplify and manipulate it? Is in the form? It doesn't look quite in the form to me. What do we need to do? What would my first step be if I needed to get this into our slope-intercept form? There it is. Nice, Devin. Nice, Dylan and Devin. We are going to add 5 to both sides. That cancels out this 5, that negative 5 there, so we get y is less than or equal to 5 halves x plus 5. Now we're dealing with this equation. And you're like, well, when are we going to start graphing? Actually, we're going to start right now. Let's do our steps. The steps will not let us down. We did step 1. We simplified it into the form we need. Now let's plot the y-intercept. Y-intercept, slope. The y-intercept is where the line is going to intersect our y-axis. So I know it's at 1, 2, 3, 4, 5. My slope is 5 over 2, which means we're going to have positive 5, a rise of positive 5, a positive run of 2. So find your next point. Rise of 5. We start with the y-intercept. We go up 1, 2, 3, 4, 5. That's 10. And then we go over to the right, positive 2. 1, 2. Here's my next point. And I could go up another 5. 1, 2, 3, 4, 5 over 2. That's where the next point would be. I can go down 5 and over 2. That's where the other point would be. Okay. And then tell me in the chat, is this solid or dashed line? Solid or dashed? That's our next step. Good. So we did this. We plotted the y-intercept. We sloped to find the next point. We know that it's solid because it could be equal to. So I'm going to go ahead and use this. Oh, yeah. Use that. And I'm just going to make a straight line. A straight solid line. Okay. All right. Now this next step is going to prep us for our next objective, which is to deal with 2 of these at the same time. Okay. So this is what I want you to do. Instead of shading everything right away, this is what I want you to do first. If I'm looking to see what y values for our last bit, where we're going to shade, we're looking to see if y is greater than or less than. It says that y is less than or equal to. So which y values are less than the line? Let's see. 5, 4, 3, 2, 1, negative 1, negative 2, negative 3, negative 4. These values are less than. So watch, I'm just going to put arrows down. Okay. For this problem, the arrows down don't really do much, but for the next problem, that's going to help us. Because we'll have 2 functions to look at, and that will be helpful to know what is in common. All right. So because I only have one equation, for example, 2, I put the arrows, but really I just need to now go in and shade in on the right side of that. The right side, which is also below the line, because y is less than or equal to. Okay. How about now? Give me a thumbs up, sideways down now. Is it getting a little better? Getting a little better? Yeah, getting a little better. Okay. So the next thing that we have to do is just deal with two of these at the same time, okay? It's not crazy additional things to it. And because I'm doing, because you missed the lesson on Wednesday, right? Your assignment is only going to be the systems where we have more than one, but it's the exact same process. You just have to do it twice, and that's why I only gave you 4 problems for homework, because you really have 8 graphs that you have to do. Okay, so we'll keep this stuff in mind, but we're going to go ahead and do a different problem here. I want you to write this down. Make a big bracket. We'll do a straightforward one. And then how about this one? All right, everybody jot that one down quick. Make a little space over here for a graph. All right. All right, here we go. First step, simplify. Give me a thumbs up or a thumbs down. Are both of these in our slope-intercept form already? Give me a thumbs up or a thumbs down. Let's see. Yeah. Y is equal to mx plus b. Y is greater than mx plus b. Y is less than or equal to mx plus b, right? So we have our parts here. We're going to do one at a time. So first I'm going to do this one. And then I'm going to do that one. So look, I'm going to do this one in red, because we have plot the y-intercept as our first step, -1. Boom. -1. Use your slope to find the next point. Slope is 2 over 1, up 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 2 over 1. I look here and I see that it's y is greater than 2x minus 1. Y is greater than 2x minus 1. So because it's just greater than, I'm going to go ahead and use a dashed line. Okay. Lastly, we have to look, is it going to shade above or below based on it being y is greater than or y is less than? Let's see. Y is greater than, so if I have my line here, the y values that are greater are up. So watch, this is where I want you just to put your arrows. Put like, 3 or 4 arrows up and down this line, just showing where you would shade. If we only had one function, we would just start shading, but we have 2. Great. Now we're ready for the second one. B, M. So now I'm going to do this one in green. Y-intercept, first thing, y-intercept. Plot your y-intercept. Is that 4? So 1, 2, 3, 4. And it is -3 over 1 is my slope. So we find the y-intercept. That helps us get ready to find our next point. We're going to go down 3 over +1. Down 3 over +1. I can go up 3 and left. All right, let me know. What do you think? Solid or dashed? What's this one going to be? Solid or dashed? Yeah. Good, good, good. The bottom one here is could be equal to. So I know that I need to make this solid. All right. We are at like 95% done. Now, would I shade above or below for this one? Let's see. Y is less than. What values are less than this line for Y? Down is less. So I'm going to put some arrows down. Just put 3 or 4. This one was going up. All right. So look, we have 3 different options here. We could shade here. We could shade here. We have 4 options. Here or here. So tell me in the chat, what is your vote? Are we going to shade in the right side, number 1, 2 up here, 3, or 4? Where do we shade? What is in common? So we know it has to be above the red. It's got to be below the green. We're only going to shade where those conditions are met for both of them. Good, Dylan. Good, Jacqueline. Anyone else? Anyone else want to take a guess? Good, Nati. Devin, double check. Nelson, good. Anyone else? Okay, so I'm just going to say it definitely is not going to be 2. Because look, the green line, we have to have it below the green line and above the red line. But if I said 2, that doesn't work because green does not go, we're not shading into the 2 region for the green. We also aren't going to do 1 because it's above red, below green. There's nothing that goes over that. Below green, above red, negates out. We can't do 4. So look, this is why number 3 is our answer. Because this is the only place where the shaded area overlaps. You're shading where it overlaps. Nothing more, nothing less. Okay? If you missed that one, do you understand now? A little bit more? Yeah, perfect. Okay. Well, give it to me. Thumbs up, sideways, down. What do you think? Yeah? Yeah? Okay, anybody want to see one more? Anybody? Because it's the same process as we did on the front of the page when we had one function. The only thing different is now we got to just overlap them, shade where we overlap. Okay? And no takers, so I'll stop the video. All right, thanks for watching.